Hey, and welcome back to Gaming for Tokens. I'm Marshall, and in this episode we're going to be picking up where we left off looking at my Breakout clone, I guess, and I'm going to be explaining some of the paddle controller stuff, like I mentioned in the last video. I'd also like to start this episode off by saying that I am trying out some new audio settings to try to eliminate some of the background noise as well as make me sound more clear. Let me know if that turns out alright. If not, feel free to leave a comment down below. I will read them and I will make adjustments as you guys, as opinions roll in. Cool. Yeah. Thank you for indulging me there for a second. So in the last episode, we talked a bit about the ball script that I have here. This guy. So making the ball ricochet off of walls, interact with things, increase in speed. I think we even talked about a little bit. And yeah, so I think we're pretty well covered there. If you have any questions, like I said, comment below. I will answer, and I'll even try to type out some code for you if you need that kind of help. But today we're going to be looking at the paddle controller. The paddle controller is kind of mean looking. It's really not, but it looks mean. It's this guy right here. Has a series of drop downs for what we would like for things, and I'll show you how to hook these up. I think I may already have gone over this stuff in a previous video on handling inputs and things, but I'm going to go over them again just to make sure. The gist of this script is going to be that it controls how this paddle down here moves, right? So if I fire the game up, you will see that I have this little rectangle down here, and I can move it left and right with the A and D keys as well as the left and right arrow. So if I use left arrow, which I'm doing right now, and I use right arrow, which I'm doing right now, or A or D, then it will it'll interact. It'll move according to those values. Now if I hold down A and left, it moves the same amount. You'll see that so if you hold down both of these inputs, the primary and alt, it doesn't like stack their movement. Some cheaper games that I've seen made, or I shouldn't say cheaper games, but I mean like some more beginner level games that I've seen make the mistake of stacking their inputs. They say that, you know, if you're holding down D, then add this to the movement vector. If you're holding down right, add this to the movement vector, and then those two stack instead of being unique operations. So that effectively modify the same vector and then powers apply later, which is what I do. So yeah, there's that, and then I also have, I'm going to be really curious if you can hear all the sirens with the new audio settings. Anyway, so you can move left and right with those two things, but I also have a drop down here for changing it from keys to mouse, and if I change it to mouse, then suddenly I'm moving the mouse, and it's moving in accordance to that. And I can move it a little bit, and I can move it a lot, so this is actually the way that I intended it to be used. And you'll see that if I move just as I hit, it bounces off in a strange direction, right? Which goes against what we said before, where here, I'll let it fail. If I fire and don't move, it's just going to bounce up and down for forever in the same vector, because it's going to bounce up, and then I really want to show you with the mouse, and I can't because if I move the mouse it won't work. But it's going to bounce up and then down and then up and then down, because the reflection of up is down and the reflection down is up. So it's going to keep doing that over and over and over again. But if I move, if I move as it's hit, you'll see that it doesn't quite bounce up anymore. It bounces off at an angle. And that's important because I want control over over spin that I'm applying to the ball. Yeah. So I'm going to cover that a little bit. I'm also going to cover how I have all this stuff set up to be able to manipulate the paddle. Yeah, so let's start looking at scripts. So the first thing we have is an enum that I'm creating, which I believe I covered enums in a previous video, but effectively what enums are is a drop-down list. If you think about it, like this is an enum. It's multiple values that you can select between that are effectively classes. It's set up kind of like a class. So you do public enum, and then you give it a name, and then you open bracket, close bracket, and in between it's a comma delineated list of variables, effectively. And then you have to set it up just like you would a class, like a custom class variable. So it's a public input configs, which is the name of the enum we've given it. So if you replace this with class, it would effectively work the same way, except this wouldn't jive well with it. But yeah, so public input configs is its name is config, and it's a new input configs. So this is effectively a way for me to list various types of inputs that I could put in. So if I wanted to, I could do an alternate configuration of keys 2. Whoa, hi. Keys 2. And then now I have an alternate configuration set up for my keys that I can select, and then I can just add variables to that down here if I wanted to. There'd be a much better way to handle an input system where I wanted to dynamically add more and more of them. I have written systems like that in the past, and I might go over a system like that in the future, but it's a lot more complicated than this is. This is specifically made for just mouse and keys. Wow, I did those backwards when I selected them. Just mouse and keys. And specifically, I have alternate controls for the keys and not for the mouse. I'm just doing what I needed to do. I'm not actually making an input system that would be like the be-all, end-all of all input systems for every game I wanted to make. This is just an input system that would work for this specific instance. So, yeah, we're starting off with public key codes, a bunch of them. 4 of them, I guess. We have left alt, right, and right alt. The reason why I have alternates is just because I've gotten in the habit of making them, I guess. So when you sit somebody down at your game and they expect a thing to go left, there's a subset of the gaming audience that uses the arrow keys still, which is kind of strange. Most people use WASD, but for example, left-handed people are going to want to use the arrow keys because their mouse is on the left side. So it's worth noting that you might not always be right. And also, I've also heard that I, J, K, and L, I think, or is it O, K, L, semicolon? I forget what exactly the left-handed control scheme for WASD is, but I believe it's one of those. You should look it up and make that maybe your alternates. I used arrow keys because it's pretty universal for both people who are left and right-handed, that being right-handed people who are not very experienced with computers, as well as left-handed people in general. I get a lot of support from arrow keys, so they know to look there. Yeah, and I'll explain how I'm using these in a little bit. The move speed is specifically for when I'm using the arrow keys. I think I also use it when I use it when I'm using the mouse as well. The arrow key, the difference between the arrow key move, or the key movement versus mouse movement is using an axis, so it is a 0 to 1 value based off of the input, whereas the key value is always going to be 1, so it's always going to be moving as fast as possible. And I'll explain that a little bit more in the future as well. In a little bit here. I also have a checkbox for if I want to invert the mouse, as you'll see here. So I'm only inverting mouse X, which is left-right. So it's kind of a weird thing. It was kind of an experiment to see if I liked it or not. I already have it all hooked up because I needed to get it there to test it. I personally don't like it, so I don't think I would ever use it. I don't think I'd set it up on options for the player to mess with. Maybe I would. I don't know. It's up to them, I guess. But it feels really weird to play the game with that inverted. The other thing I have is a max move value. Now this is important because what this does is it limits the left and right movement of the paddle. So I can't go any farther left than this, and I can't go any farther right than this. And you'll notice up here that that's 7.75, my max position X, which correspondingly, my max move is 7.75. So if I go left, it's negative 7.75. I have this value determines how far left and right I can go effectively. Well, not effective. Well, I guess effectively. I don't know if that's the right word. Then we have anchor offset. The anchor offset is kind of a complicated thing, I guess. I don't know. You'll see that the anchor offset here is 0, 0, 0. But when I hit play, I think it might set it. It doesn't set it. Oh, no, I know what that is. Okay. You'll see down here that I have a anchor position. My anchor position is basically my initial position for the object. So because this paddle isn't at 0, 0, 0, I can't do my max move. I can't figure out how far I've moved unless I store my initial location and then compare my current location against that to see how far away I am. So this anchor offset is an offset for my original position. So for example, if I wanted the paddle to start over here, then I need to tell it that over here is actually the center of my path, right? So I can do that by saying we're going to move you over here I need to turn numlock on, 2.25, and then I'm going to say that my offset is going to be negative 2.25 on the X. And if I play that, then you will see that I still can't... Oh, that doesn't work very well, does it? Where? Oh, I think I know why. Really? Negative 4.5? It might need to be that. There's loud people outside of my apartment, I'm sorry. Yeah, I'm not quite sure what's going on with this, to be honest, but maybe my anchor position just doesn't work. It's possible. I haven't really tried it. I didn't really need it, because I just decided you should start in the middle. Anyway, that's the intent of that, is that you will be able to move the original position of the object over and then compensate for that with this anchor position offset. But it doesn't work right now. We can look into that as I go over the scripts, and I might figure it out. We also have a launch key. So the launch key is for when and in this instance you'll see that it's space. I also have a launch mouse. Oh no, it's not centered. That's the worst. You need to be there. Alright. So you'll see that with keyboard, it is space. So if I hit space, it launches the ball. That's what that does. So I'm going to do that, and then I'm going to change it from keys to mouse, and you'll see that when I click, it fires the ball. And it fires the ball based on either the space bar, which is what I have selected here, or is mouse button 0. So if I set this to mouse button 1, and then I come over here and left click, you can probably hear me clicking, I hope. It doesn't fire, but if I right click, then it will. So that sets the mouse button and the key that I'm using for that. So something that I don't know if I've covered before, if you say public key code and then you give it a name and you say it's a key code, the way that key codes look, they look like enumerators because they basically are. They're like a modified enumerator, sort of. It looks like this. These are all the keys on your keyboard, basically. So yeah, if you want a custom input system, using enumerators is really, really handy for that. It's really handy for a lot of things, but specifically I found that it's particularly helpful with custom input systems and being able to control what keys do what and how they do what and all that stuff. So mostly because the inputs for keys are already run off of enumerators, and you can convert enumerators to integers if you need to for mouse buttons. So it's pretty handy. The only thing that gets messy with that is if you're converting accesses from enumerators to accesses and all sorts of stuff like that, because an access is a float, and floats don't really jive well with enumerators. Anyway, kind of a small tangent, but yeah. So that's what launch key and launch mouse do. The transform ball seat is a position in the paddle that I have here. The ball bay is what I'm calling it. And that is it's a position inside of the paddle that I want the ball to go to when it despawns. So when it hits one of our catchers, which I talked about in the last video briefly, basically when the ball goes out of bounds, I want it to pop in at a place on the paddle seated in such a way that it looks like it's sitting on the paddle, which is how the game starts, right? We have the game starting with the ball being seated on the paddle. So when I start the game here, you'll see that underneath the ball bay, I actually have the ball. So it's actually parented to that transform. You'll see in a function later on down here called seat ball, I actually parent the ball to that transform. But anyway, going back in. Excuse me. That's ball seat. The next thing I have is launch effects, which is just it's just a game object that I'm. So, here's the ball bay thing that I hooked up. This is just a prefab that I have hooked up for when I hit. So this right here, that launch effect, that's that launch effect. Yep, and it's a different effect, I believe, when you hit. I might be hooking up the same one, but when I... I hate it when I get it in like a sideways spiral like that. A sideways spiral. That wasn't even a spiral. It's nothing close to a spiral. Anyway, those might be the same effects. I'm not exactly sure. I probably have the same effect hooked up for both. But yeah, that larger explosion there, that guy, is the hit effects. Oh yeah, it is. It's just the paddle hit effects. Well, I could, in theory, hook up a second effect for when I'm launching the ball if I wanted to. I also have this launch spin scaler. This is for the spin transfer on the ball script. So when I feed a number into the ball script for the direction that my paddle's moving, this is what I multiply that by. I can modify it to be like, I don't know, we can try 5, and it'll be ridiculous. So if I'm moving really at all, it'll transfer a ton of spin. Oh, that's cool. Monodevelop just decided to... Sweet. So if I'm moving just like a little bit at all, it'll like spin wildly off to one side. If I can, move and hit it at the same time. That was pretty wildly off to one side. Not really. I might be normalizing that somewhere. And if I am, then that's probably all for moot. Yeah, it looks like I'm normalizing that. Oh well, that's a shame. But that's what the intent of that is that I would be able to modify the amount of spin that I apply to the ball from the paddle. I believe I'm doing that on the ball though, so I don't think I need that anymore because I have this paddle spin transfer. Yeah. Anyway, and then I have all my private variables for if I'm enabled or if what the anchor position is and the base offset, which is all stuff for me to like know independently of whatever, of where I started and where I am currently. I need all this information to be able to reference how far I've moved, where I've moved to. My last position is for the velocity reasons, so I know what direction I'm moving in and at what speed. That way I can transfer that as a spin value to the ball. And then I have a ball-seated bool for if I'm currently holding on to the ball. Because if I am, then I want to be able to use the inputs to launch the ball, and I want to be able to see if I have a ball seated on the paddle. Yep, and those are all my variables. So moving right into how the thing works. So the first thing I do is I set the base offset to my position. So that's the idea there is how far away from 0 am I, and that'll give me exactly that. And then the anchor position is my position plus my anchor position, which is 0 at the moment. I think what I wanted to do here is my anchor offset. That would make a lot more sense and probably explain why that's not working. See, I told you I'd figure it out. And then I set my last position as my current position, which makes sense because that's where I last was. Meaning this is the first frame. This is like, where was I before? Nowhere. Cool. I was where I am now, I presume. And then if I can find the game object ball, I want to seat it, because that's the first thing I want to do is seat my ball in my paddle because I need to. Initially, I probably shouldn't be doing this here. I should probably be doing this in a bigger script that I have that controls the game side of things, which I will talk about eventually, but not in this video. I should be doing it there, not here, probably, and I might change that during that video. But for now, I'm doing it in the paddle. I think the reason why I'm doing it in the paddle is so that I could do this demonstration without having to explain that other script. So it's probably a good thing that I'm doing it here now. But yeah, so this function here, seat ball, is down here, and it takes a game object. How I'm finding this game object is I'm saying find game object with tag at ball, and I have my ball game object set with a tag and layer of ball. So I'm using a lot of tags and layers here. Specifically, I'm using please open the list. Okay, I'm using ball, paddle, catcher, and brick. Those are the paddles that I made for it. Paddle, ball, brick, main is another tag that I have. I don't have a layer for main because I don't need a layer for main. Yeah, so those are the different things that I have. You'll notice all my other tags from my previous videos are still in here. Try to ignore those, please. Yeah, don't get confused by them is a better way of saying that, I think. All right, going right into our update loop, we're going to set our last position to what our position currently is. because we're going to be moving the paddle this this frame. So we want to store where we are, so then when we move, we'll reference where we were. After we've moved. So if we're enabled, we're going to do all of this stuff. And the reason why I'm setting my last position out here is because I set my current velocity out here as well. And if we're not enabled, our velocity should probably be 0. And if I set my last position to transform.position, and then I take that and I subtract my last position from it, in theory it should be 0 in all cases, unless we're enabled. So if we're disabled, then our velocity should be 0. Therefore, we shouldn't be applying any spin to the ball. That's my mentality here, because we're not enabled to move the thing at all, so it shouldn't be moving. Anyway, kind of a weird roundabout way of explaining that, but I hope that makes sense why I'm doing that outside of this if. But if we're enabled, then our movement vector is going to start off as 0. This is a local vector 3 here that I'm going to modify as I go down the input lists and see what inputs I'm applying to it. If our config is keys, that's up here. Remember the config enumerator that I set up here? If we're set to be using keys, then I want to start looking for left and left alt. If either left or left alt are down, basically, if their input value is 1, then we're going to say move the vector plus negative to the right. I could do a minus equals to the right, but I figured this was more consistent with one another. Instead of doing a negative plus or negative equals and plus equals, I could just do I can add the inverse of right, which is left, so I can add left, or I can add right. To me, this makes more sense. You can do it either way, though. For the record, the other way is to do it like, this. So you can do minus right, plus right. I chose to do it like this. They're the exact same thing, and I think they're just as efficient as far as I know, and if they're not, that's weird. But, yeah, I choose to do it this way just because it makes more sense to me. But do it however you want. So our if statement is, if left or left alt, go left. If right or right alt, go right. That's really everything. And this is kind of what I meant earlier by my inputs don't stack together. So, for example, another way to do this that I would consider wrong is if input dot get key left alt. Like that. So this right here would technically work, but what it would mean is if I held down the left arrow and A, I would move twice as fast, which is bad because both of these ifs are going to fire off. And the only other way that it would make more sense is if I did an else. Like this would work, but to me it's messy because it's 2 lines. You could do it in less. You could do it in less statements. You could do it in less arithmetic. You could just do it in logic. What is that called? A logic statement? Is that what it's called? I don't know. I forget what those are called. This thing here where you have an or. The else is essentially the exact same thing, except if you have the first key down, it won't even look at the second key. This looks at both keys and it realizes that you have both of them down, but it only applies the value once, essentially. And then I do the exact same thing for right, except instead of adding negative right, I add right. Yep. And the last thing I look for is if launch key, then I launch the ball. And launch ball should have, when I go to it, it checks for the ball seated bool, which ball seated is set here in seat ball. Okay. So the next thing I look for is the mouse if mouse is set as my config. And if it is, then I want to see if we're inverting the mouse. And if we are, then I'm going to apply the negative value of my x-axis on my mouse times transform.right. So I'm taking because input.getAxis returns a float. It returns a float between -1 and +1. And as it's a percentage of the the amount of input you're applying using your mouse. So if you're applying full input, so if you're going as fast as you can with your mouse to the right, you're going to get a input value of 1 because you're going 100% in the right direction. If you go left and you're only going about half the speed that you can go with your mouse, then you're going to be going 0.5 negative because you're going left, which is negative on the x. Again, this is y and this is x in the y, x in the world of 2D mouse inputs. So if I'm moving to the right, then in theory I'm moving positive along the x, so that's going to be a positive float value. I'm going to multiply that by my right vector 3. That's going to convert that input into a direction on the right axis. And then we're going to subtract that from our movement vector. If we're not inverting our x, then I'm not going to subtract, I'm going to add it. And I'm going to do the same thing, same math, it's just an add instead of a subtract. And then I'm going to check to see if our mouse button up is launch mouse. So I'm seeing if we have released whatever mouse button we're looking to release to launch the ball. And the reason why I went with mouse button up is it felt kind of like a pinball game. Instead of like pushing a button and launching the ball, I'm holding a button down and releasing that to let the ball go. It's kind of a designery thing, and I like it a lot more than pushing the button down. It feels really weird to, like, I guess the way to word it is, do you want to feel like you're launching the ball, or do you want to feel like you are releasing the ball? Because if you're releasing the ball, then you want to release the mouse button at the same time. If you want to feel like you're launching the ball, you want to push a button. And I wanted to be able to release the ball. It's a really, really subtle thing, but a lot of the time design is about an amalgamation of subtle things, in my opinion. Sometimes it's an amalgamation of really, really obvious things, but sometimes, every now and then, you get the ability to control finite details about your game that make it feel better. That's usually where feel comes from in games, if you've ever heard that term. Anyway, moving right along, the movement vector is going to be multiplied by the move speed times time.delta time times time.timescale. So this whole thing right here is just time, basically. So this will work with bullet time. If we decide to modify time scale and like go into slow motion, this will work with that. The movement speed we set up here, that's how fast we want to be able to move. And yeah, we're just taking our movement vector, which is technically a direction still at this point, I'd hope, and then we're multiplying it by our movement speed. Yep. The last thing we want to do is we want to see what our distance is. If our distance between our anchor position and our current position, plus our movement vector, is greater than our max movement, so this is the position that we are potentially going to be at. Because again, we haven't actually moved yet. We do that down here. If our distance from where we are to where we want to go moves us outside of our maximum movement range, then we want to do some math to rein that in so that it becomes within our movement range. So I'm saying that if the anchor position.x is less than our position.x, so if we are to the right of our anchor, right, that's what this means. Because if our position.x is less than, that means it's to the left of where we currently are, then we want to make our transform.position equal to our right vector times our max move times plus our base offset. So the idea here is that if we are to the right of our vector, then we want to go as far right as we possibly can, because we're clearly hitting our maximum movement ability. So we're just going to manually set it so that you're as far to the right as you can. So we're going to snap you to that point. And then otherwise, if we are not to the right of our anchor, I'm assuming we're to the left of our anchor, because those are the two options. And I'm going to snap you all the way to the left side, which is, I believe, the same math, except it's negative transform.right. And that's as easy as that. Otherwise, we're going to move. We're going to modify our position by our movement vector. And that's going to be it. We're going to set our current velocity to be our position minus our last position, because in theory, our position is now either greater or more negative. It is different than our last position. And this will give us the difference as a vector 3. So if it's negative, that means we move left, and if it's positive, that means we moved right. and we know that now, and we know what the intensity of that is. So, for example, if we only moved a little bit, then this current velocity is going to be a little bit, which is great because that means that it's a direction and it's a power and a direction, which is actually a force. So that's actually not right. Maybe velocity is the wrong term, by the way. Feel free to tear me to shreds in the comments, physicist, if that is correct. But that's what I'm using it as. I'm using it as a direction vector with an intensity, I guess, of movement. So a speed would be better. Now, I think acceleration is actually what I'm looking for here. Whatever. You get what I'm saying. This is going to control the amount, the distance that I moved and the direction of that distance. And that's it. That's all I do on my update. So I'm checking for inputs. I'm applying those inputs as values to a vector 3. I'm making sure that vector 3 doesn't move us outside of our bounds. And if it does, I'm reining that in. And then I am setting that position to move us along that direction. All of that just so you can hold D and go right. Great. So moving on, I have a get velocity function here. This is just so that when I apply spin to the ball, I know what my velocity is. And if I wanted to, I should say, where is that? Where are you? Launch spin scalar. This guy should be multiplied here. Look at that. I did it. Oh, wait, no, that's a launch spin scalar. Oh, I might be using that somewhere, actually. My bad. That's actually, right. So going back to this variable here, I said it wasn't working before. It is working. It's working just fine. The launch spin scalar is only for when I launch the ball. Because the ball doesn't technically collide with the paddle when it's launched, it won't actually have any spin value on it. But this was like a weird bug that I found like part of the way through making the whole system, was that I wanted to be able to move left and apply spin to it to the right. So when I go left, it actually does do that. Here, I'll try to demonstrate it a little better there. Shboop. And if I go like that, you'll see that it goes off at a left angle. Now, if I set the launch spin scalar to 0, you'll see that it won't actually do that anymore. If I go right and I launch, it goes in a straight line up and a straight line down and a straight line up. But if I set this to like 3 and I let this go off the screen and I go right, it goes off at a crazy angle. So that's the intent behind this, is specifically to handle launching, because the ball doesn't collide with the paddle when it's launched, and I wanted a way to be able to give the player a little bit of strategic edge to the game, I guess. Again, a little thing, but as a designer, means the world to me because it gives the player a little bit more of a feel for how the game works. It's anything like that, anything that affects the feel of a game is what separates really, really great games from kind of like shovelware type crap games. Like the kind of games that they're games and clearly effort was put into them, but they're not great. They're not something that you're going to play for a little while. Like, it's impressive if it's like your first project or something like that. But like a little thing like that, and a little thing like the spin when you hit something, or the release mousing button, the release mouse button to launch the ball. Little things like that are what'll make the game feel so much better and make the people actually want to play your game. Not saying that this Ricochet game is the greatest game in the world. It's kind of it's a little game, but taking that knowledge and applying it to any game that you're going to make in the future is vitally important. As a designer, I stand fast behind that. The feel of the game is the most important thing. Anyway, I will get off my pedestal for a second and continue talking about my scripts. So I have a function here for seeding the ball. That's the next thing. So again, this is called by my catcher script, which I have here. It doesn't do a whole lot. It just does this. But specifically, it's going to, if it found a ball, it is going to find the paddle, and it's going to send a message to my paddle called seat ball, and it's going to give me my ball object. So if I go to the paddle here, seat ball takes in a ball object. It's as easy as that. So when my catcher on trigger enter, because they're triggers, if it finds that the game object that collided with it uses the ball tag, which right now is ball, then it's going to send that game object to my paddle, and you could ignore this guy down here. I'll talk about this one in a later video when I talk about how I made everything a game and kind of cohesified everything with a single script. But for the meantime, I'm finding a game object with a tag, my paddle tag, which is up here. It's paddle, and if you notice in the game, my paddle is tagged with it. I'm going to send message to that thing, tell it to seat this ball. And when it does that, it takes in the thing. It makes sure that my ball actually has the ball component, because it needs that. So it's making sure that something random didn't somehow get tagged with ball and then fed through a catcher and then spit out to this. And it's like, here's your ball, when really the thing isn't a ball, because that would be a bad situation to be in. But I try to catch for that case here. Very, very rare possibility that's going to happen, but better safe than sorry. So yeah, is it a ball? Great. Do I have something already? Do I already have a ball in my midst, as it were? If not, oh, actually that's not even what I'm checking here. I'm checking to see if I have a ball seat transform. I should also be checking, and whoa, that's not and not ball seated. Whoa, ball seated. So I'm checking to make sure that I have the transform that I want to parent everything to, and I'm also making sure that I don't have a ball already. Because the situation where I would already have a ball is if I have multiple balls. There's going to be a lot of ball jokes in this, I have a feeling. I don't know. We'll see. I hope not. Well, who am I kidding? I hope so. Anyway, so if we already have a ball seated, that means that there are multiple balls bouncing around this game, and that means that I don't want to catch another one until I've already launched the one I currently have. So that'll catch this case as well. So my ball is going to be my I really love this line and I really want to read it out loud. Ball equals ball object get component ball. So ball is a class, as we've seen up here, and ball lowercase is my local variable of that class, and I am getting the component ball from my ball object. Everything about this makes me endlessly happy right now. God, I'm endlessly happy by the amount of balls all over my project. There we go. There's the joke. There's the joke, guys. We did it. So ball set enabled false. So that in here, if you remember from the last video, I have this set enabled bool. That basically disables it so that we currently, so that it doesn't bounce anymore. It doesn't like ricochet off of walls or the paddle or do any collision detection or try to move. It just kind of disables the whole script as a whole. Disables the whole script as a whole. Disables the script as a whole so that it doesn't try to do anything while we have it like held in the paddle. We're also going to set the speed of it to 0, which is something that I kind of do here already. I already have set speed, current speed, but oh no, I don't. I don't set it at all. This is for when I re-enable it. Well, I'm going to set it to 0 in the paddle because why not? I can. I should probably do it in the ball script, but I won't because I'm silly. I think it's because I want to be able to disable it and I want it to be able to continue along its current speed until that speed decays. I wanted to be able to kind of like turn it off but then have it like slow down eventually. I wanted to have some sort of acceleration. Whatever. I'm not doing that anymore, so it doesn't really matter. I'm doing it here. So this says that, wow. I set the speed to 0, and then I make sure that the ball transform is my transform up. So we are kind of in sync with each other. So the ball paddle's looking up, I'm looking up, and it's ready to be launched whenever I need it to be launched. I set the position to the ball seat position, and then I actually parent the ball to that object. The reason why I'm doing that is so I don't have to add in any like complicated update position stuff for if I have a ball seated, I need to move the ball to the object of the transform that it should be attached to. I don't want to get into any of that. That's a mess. So instead, I just parented it to the transform that it should be linked to, and voila! Now I don't have to keep track of any of that stuff. And I just make sure in my launch ball script down here, where is it? Here, that I unparent the ball from the thing that it's parented to and just cast it off into the world. In a lot of games, this kind of thing wouldn't work. In this little simple thing, it works great. So but I'm going to talk about the script now before I start jumping around. So I want to launch the ball if we have a ball seeded, because we did set the ball seeded to true up here, as the last thing we did in our seeding of the ball, is we made sure that we checked that bool to true. So if that is true, then we want to set the ball transform to null. Well, this is the local variable, and we're setting it to null by default. That's what we're doing. Sorry. Because we want to be able to gather the position of our ball and be able to unparent it and like re-enable it and that kind of thing. So that's this is the starting of that. Here's my local variable, and then we're going to say, hey, I want to go through all of the children attached to my ball seat, and I want to see if any of them are a ball. The idea here is that I might eventually want to parent something else to the ball seat, like say an effect that tells me that I have a ball, or like a tutorial object that says, hey, press space to launch the ball. In any of those cases, I don't want to unparent any of those objects from my ball seat, so I want to find the ball and specifically grab that object. So I do that here. This is how I do it. I go ballSeat.childCount is the amount of children on it. It is an int value. So that's my for loop. I'm going to go until I've looked at all of them. And if the ball trans is null, I want to keep looking. The reason why that's the case is if I set my ball trans, I've already found the object. I don't need to find another one. So I just want to end my for loop there. So that's what this little guy here does. Then inside this for loop, we're going to say, hey, if the object you're currently looking at, if ballSeed.getChildI, which is the child we are currently looking at of ballSeat, if its tag is ball, then clearly we've found the ball. So we're going to set that guy here. We're going to say ballTrans equals ballTransGetChildI.transform. So again, look through all of ballSeat's children, find the one that is tagged with ball, find the first one that is tagged with ball, rather, pull that guy out, and say, here's the ball, we have it. Then we're going to say if ballTrans does not equal null. So what this means is if we have found a ball up here in this loop, then we're going to make sure that thing's parent is null, which means that it unparents it from everything it could be possibly parented to and kind of casts it into the world. We're going to send message set enabled true. So as opposed to how we did set enabled false here, because I already had the ball object component, which I don't have down here. Just because I didn't want to put that extra line of code in just to do this. I can just do a send message. So I'm going to send a message to it, ball enabled true. So we're going to re-enable that ball now that we've unparented it from our paddle seat. We're going to make sure that we set our local, our private variable ball seated to false. We no longer have a ball seated. We're going to make sure that the ball trans up is this isn't really a reflection vector so much as it is an average of a vector, right? We have our get velocity, which is the velocity of our current object. We're going to multiply that by our spin scalar, which I talked about earlier. So that is the direction we are going multiplied by how much we want to affect it in that. We're going to add our vector3.up, so that's going to be up, I guess. And then we're going to divide that by 2. So the idea here is we are, this is also a negative vector, by the way. So if I took this away, then we would go in the direction that the paddle is going, which feels weird. It's because like if you take your pointer finger and you put it on your palm and you move your palm in a given direction, you feel the drag of your pointer finger going with the palm of your hand, which means that effectively the direction that your pointer finger is pointing in is from your palm to the hand that your pointer finger is connected to is away from the direction that your hand is going. That might have been really confusing. I'm sorry. But the gist is if you took like a ball and you put it on a piece of paper and you pulled a piece of paper out from underneath it, the ball would roll in the opposite direction of the movement of the paper. because that's how spin works, right? That's how friction works. That's effectively why I'm applying a negative vector here. I'm saying, hey, I want to figure out what direction you're going, and I want to multiply that vector by how much I want to do that. But I also don't want to apply that to the ball. I want to apply the inverse of that, the opposite direction, because that's the direction we're going to be going with the ball. We're going to average that by our vector 3.up. The way that you average vectors is by adding them together and then dividing by 2. So it's pretty simple. If we wanted to take up and right, we add and we want to find like the 45-degree angle from that between those two vectors, we just add up and right and then divide by 2. So this is effectively what I'm doing, but because of this launch spin scalar, this actually makes this right vector much higher than my up vector. So by adding these two together and then dividing by 2, if this launch spin scalar is high, then that's going to multiply my velocity much more in that direction. So this up will be 0.5, but this get velocity multiplied by the launch spin vector is going to be much higher than that 0.5. So we're still going to be looking to the right side. Yeah, and that's where my ball trans up is being set to. So the way that you can kind of visualize that, if I'm moving this way with my paddle, the ball is going to be facing this way when it launches, right? So that is effectively going to apply spin on the ball going this direction, so it's going to go woof off that way. Hopefully that makes sense, because I can't think of a better way to describe that. The last thing we're doing here is I'm checking to see if I have a launch effects hooked up, and if I do, then I'm instantiating it where I need it to be. Yeah, and the last thing I have here is a warning for myself for if I hold myself to launch a ball, and I did have a ball seated, but I found an object that was not a ball. Which this warning should never fire off. If it fires off, I have something really, really weird going on. Like I have something parented to the ball seat that isn't a ball that has the ball tag. That would be, and I have seated a ball as well, and I found the other object first. So it's a really, really random set of, well, not random, I guess it's a very controlled set of circumstances that would happen in, but a very rare set of circumstances. I just wanted to make sure that I put it in here. Yeah, I love my, I don't know, man. I'm boarding it. So if that happens, then it doesn't actually launch anything. Yeah. So let's see what we have going on here. Yeah. So this is our this is the paddle. This is how it works. And that was everything in the script. That was from start to finish. That was all of it. If you have any questions with how I did any of my input stuff, please let me know. If you guys want to see that complicated input system, that would be super cool to show off. I've done a lot of work with input systems, mostly because I really don't like Unity's built-in input system. So I've kind of I've gotten pretty quick about making my own from scratch, using custom classes and enumerators and things like that, to kind of cobble together an input class structure that I can then save off into files, effectively letting the players have an input selection screen, and they can save that information locally on their PC and like have a file that controls a input layout for a game, which is kind of handy. But I can talk about all of that stuff in different videos in the future, how to write save systems and how to do input stuff. For the time being, in the next video, what we're going to talk about is where is test? Oh, it's in here, isn't it? Test. We're going to turn this guy off. And I'm going to drag that out of there. And we're going to do these guys next. I'm going to show you how I got these bricks. Hopefully this might break the game, by the way. Oh, it broke the game. I knew it would. Oh, it's the worst. All right. Well, here, I'm going to do, I guess, this. I'm going to enable everything. Oh, that's not okay. Anyway, I'm going to show you guys how to set up these bricks so that they can have health and you can damage them. They give you points and then they destroy themselves. And you can kind of start to gather how I'm building this game a little bit more, I think. Yeah. This is dangerous. Oh, yeah. Okay, I screwed it up. That's the reason why you'd want that that curve, by the way, is so you can do things like this. where you can get the ball kind of moving in a direction out of the gate so that you can like bounce it around inside of there like that. That's the strategy, right, of these breakout games, which isn't much to say that there's not a lot of strategy in these games, but it's anything that you can get out of it is better than nothing, right? So yeah, I'll be showing you guys how these bricks are set up and how I got them to destroy and how I got them to do like the shrinking that they do for the red border and all that stuff. And yeah, if I have time, I will also show you how I got those point values to show up at some point. But yeah, thanks for watching. If you have any questions, let me know in the comments, as I'm sure you will. If you have any requests, again, leave them in the comments. I will find them. The current state of the channel is that I don't get very many comments, so I see all of them and I can respond to all of them. Yeah. So if you have any questions or comments or anything like that, you will get a response from me, believe it or not. Yeah. Thanks for watching, and bye-bye.